Okay, so I've been intrigued by this question proposed by Reagan Dionisio. Hopefully I pronounced that correctly. So basically we have four congruent squares and we're to just find theta. And I've seen a lot of really cool solutions to this problem posted on the site. And so I was just thinking of one more. I don't usually think first to vectors and the physics type of solutions, but this is a pretty cool solution, I think. And first off, there's the equation for the angle between two vectors, and it's this one right here. Cosine of theta equals v sub 1 w sub 1, basically the dot product of vector v and vector w. So I'm basically going to call one of these vector v and the other vector w, and then we have the magnitudes of vector v and vector w we're dividing by. So for this question, it is not three-dimensional. So actually there's only going to be two dimensions. So just the first and the second dimension. So first thing I want to do is standardize both of these vectors. And what I'm going to do is call this one, that point right there, is the origin. And so if the tail of a vector is at the origin, then it's already in standard position. But of course, we can pick up a vector, any vector that we like, and we can move it. So I'm going to move it. It's going to retain its direction and its magnitude. But I'm just going to move it so that it is also standardized. And so everything kind of changes position a little bit, but the angle between the vectors is still retained. Still going to be that same angle theta, because all I've done is effectively move this vector over into standard position, created a parallelogram, and so we're going to have an angle and an angle that are congruent to each other. So let's find out what that angle is. And so we go to cosine of theta. I'm just going to use this formula. So I need to figure out the dot product, and I guess we could name them. I'll name this one vector v, and I'll name this one vector w. And so because it's standard position, all I need to know is where it terminates. And so this one terminates at 3. So it's over 3 and up 1. And this one terminates at over 1 and up 2. 2. There we go. And now I think we can do the deed of solving this for the angle in between using the formula. So first off, let me write out my vectors. I'll write them out like this: 1, 2, dot with 3, 1. There are so many different ways of notating vectors, and then I'll do it like this: 1, 2. And that's going to be the magnitude, basically Pythagorean formula. And 3, 1. All right, so I'll just essentially do the dot product over the magnitudes. So the dot product is going to be 1 times 3. Those are the x positions of that vector, horizontal positions. 1 times 3, 1 times 3, plus 2 times 1, 2 times 1, and divided by. Now dividing by, I'm going to basically do Pythagorean formula, but it's going to be a 1 squared plus 2 squared. 1 squared plus 2 squared times 3 squared plus 1 squared. And that's going to be equal to 3 plus 2 5. And maybe I'll remind myself that that is the cosine of theta. And divided by 2 squared 4 plus 1 is square root of 5. And that's times 3 squared is 9 plus 1 is 10. Square root of 10. And that is equal to 5 divided by the square root of 50. Now what I'm going to do is a little bit of simplifying. Cosine of theta is equal to 5 divided by, let's take the square root of 50 and turn it into the square root of 25 times the square root of 2, which is equal to 5 over 5 times the square root of 2. And when we do a little bit of cancellation with the 5s, we realize that the cosine of theta is equal to 1 divided by the square root of 2. And that might already be very familiar, very famous ratio, 1 over the square root of 2. But let's go a little bit more old school and use the 1 trick to rationalize the denominator. And so that gives us the square root of 2 over 2. Now this is so famous of a ratio for cosine that we don't even have to go to our calculators. So it's cosine of theta equals square root of 2 over 2, or that is a 45 degree angle. So theta is equal to 45 degrees. And I was also thinking about another way to solve this using a little bit more of the trigonometry. And of course, the trigonometry, we could use the law of cosines. And so my setup will be really similar. So I'll move this over, and then I'll also have another side. So looking at this now, I have a triangle, and of course that is my theta again right there. So I have a triangle, and I think with this triangle I can find all 3 side lengths. Okay, so I've already done a little bit of this in the previous problem, but let me go ahead and do 3, 1. And then here is 1, 2. And so the magnitude of, or the length of the magnitude of this side is going to be that 1 squared plus 2 squared is going to give me square root of 5. And then this side is going to be 3 squared plus 1 squared, square root of 10. So that kind of stole from the previous problem. And then the magnitude of the third side. And so I can say that this third side, let's call it C. C is equal to, and I can use a little distance formula. Let's see, 3 minus 1, 9 squared. And let's go backwards this time. 2 minus 1, 2 minus 1, 9 squared. And C is equal to, C, that's 2 squared before, plus 2 minus 1, 1 squared, or 1. Just double checking, make sure that that's correct. C is equal to the square root of 5. C equals the square root of 5. And so here's the law of cosine. Cosine of theta is equal to a square plus b square minus c squared divided by 2 times a times b. Cosine of theta is equal to, well, what I'm going to do is say that a is that side, I'm going to say B is this side. And then C is going to be opposite my angle. And we hope that this also is going to be a 45-degree angle. So here goes. A squared. Square root of 5 squared is 5. B squared. Square root of 10 squared is 10. Minus C squared. Square root of 5 squared is 5. Divided by 2 times A. A again is square root of 5. B, square root of 10. So the cosine of theta is equal to, you can see the 5 and the minus 5 cancels out. So that leaves us with 10 divided by 2 times the square root of 50. Or 10 divided by 2 is 5 divided by the square root of 50. And let's keep going. Cosine of theta is equal to 5 divided by, let's break up the square root of 50 into a known perfect square. Square root of 25 times a non-perfect square. 25 times 2 is still equal to 50. So square root of 25 times the square root of 2 will equal the square root of 50. So cosine of theta is equal to 5 over 5 times the square root of 2, which is 1 over the square root of 2. Oops, I'm not getting that in there. So it looks like so. And there's that very familiar 1 divided by the square root of 2 again. And we can already identify, if we know the ratio in that format, we can already identify that the cosine, that's the ratio for the cosine of 45 degrees. So we could also rationalize this denominator. I call it the 1 trig, multiply by the square root of 2 over the square root of 2. And what we end up with is square root of 2 over 2, which might be the other way that you would see this particular ratio. So very famous, so famous, no need to go to the calculator. So once again, 45 degrees is the angle in between basically the 2 vectors. So there you go, 2 different ways to solve. And that was fun.